Alright guys, I'm going to finish up. I'm going to do just a couple of these questions. This video won't be as long as the last one was. I just wanted to go through a couple of this and then just kind of summarize a few of the things that you need to know for the test. So we've got a Wheatstone bridge here. We've got a 10 volt power supply. Resistors R1 and R2 are 600 ohms. R3 is 1000 ohms, and we have a PT1000 as our variable resistor. And we're looking at our PT1000 at 0 ohms is 1000, or at 0 degrees Celsius is 1000 ohms. Temp goes up by 30 degrees Celsius. We've got 5 ohms per every 1 degree Celsius. I'd like you guys to pause that and work through it, and then come back when you're done and we'll finish up the rest of the question. Okay, so we've got 10 volt power supply, right? I already have 5 volts written here. If we have both resistors the same, remember that that voltage gets split evenly between those two resistors. So we have 5 volts at the positive lead of our meter. We've got 1000 ohms and our PT1000 here. But we have to figure out what the resistance of our PT1000 is at 30 degrees. So we know that we are 5 ohms per every degree. It's weighing up 30 degrees, so 30 times that. So that's going to be 150 ohms. So our PT1000 right now is at 1150 or 1.15 k-ohm. Now we can calculate what the resistance is through this branch. So we have our current is equal to 10 volts, which is the supply, and these two resistors obviously have to have the same voltage drop as what the supply is. So 10 volts divided by 2,150 ohms, which is the sum of the two. So 10 divided by 2,150. This gives us a current of 4.65 milliamps, and that current is going to go through resistor 3 and resistor 4. So if we have 4.65 milliamps going through our PT1000, and we know that there's 1,150 ohms, we can calculate out what our voltage is. So we have our current, and current times resistance, as you know, to find voltage. So 4.65 milliamps times 1,150 ohms, and that gives us 5.35, yeah, let's round up, 5.35 volts. So that is the voltage drop across my PT1000. And if I were to take a meter and go from my negative to here, across that, it would be the 5.35. We've got 5 volts there. So we have 5.35 volts at this point. And then remember how I said with the meter takes the positive lead and uses that as its starting point, and then it subtracts whatever's on the negative lead. So if we want to know what's on the meter, we take our 5, subtract 5.35. So 5 subtract 5.35, and we get negative 0.35 or negative 350 millivolts. So negative 350 millivolts on that one. So I hope you guys got that one right. Okay, so I'm going to give you another one here. Okay, so we are gonna make this next one. This next one's going to be a thermistor. And our thermistor, we're going to say at at 20 degrees Celsius is at, let's do 20,000 ohms. Okay? And 20 degrees is at 20,000 ohms, and that's going to be our set point. It is going, I'm just going to do a constant change on this value, on this one. For every degree, it's going to change 1,000 ohms. So we're going to make our R3 20,000 ohms, or 20 k ohm. And we're going to say that the temperature goes up 2 degrees. Okay? So temperature went up 2 degrees, and remember what type of device a thermistor is. Is it a positive temperature coefficient or a negative temperature coefficient? So keep that in mind as you go to do this question. So we start, it starts at the 20 degrees of the 2,000 ohms, or 20 k ohm, and we've changed 2 degrees. So pause the video, go through the question, and then come back and we'll finish that one up. Okay? All right, so we had these two values are the same, so we know we've got 5 volts on the positive lead, and we've got 20,000 ohms, but we know that the temperatures went up 2 degrees. However, with a thermistor, majority of them, and as I tried to get you to the default, is that thermistors are negative temperature coefficient devices. So if it's went up 2 degrees, that means the resistance has went down by 2,000 degrees, right? So if it changed 1 degree, it would go down 1,000. If it changed 2 degrees, it would go down 2,000. So we know now that the resistance at our thermistor is now 18 k ohm. And now we can go through and figure out what our current is. So we have 10 volts as our power supply going through between the 2 resistors, divided by the sum of the two, so 38 k ohm. And that is going to give us a current of 10 divided by 38 k ohm is a very small number. So we have 263 microamps. Okay, so now we take that value, multiply it by the resistance of the thermistor. So our voltage is going to be 18 k ohm times 263 microamps, and depending on how many decimals you saved in your calculator might change your answer slightly, we multiply that by 18,000, and we get a voltage of 4.737 volts. So our voltage here, 4.737. So that means that it's also 4.737 here. So looking at our meter takes the positive lead value as a starting point and then subtracts the other one from it. So it's going to be 5 subtract 4.737. So that should be 0.263 volts, I believe. Yeah. So 263 millivolts is the voltage that's going to be on our meter. Okay. So hopefully you guys are starting to get how these work, and that they're not too bad for you. I'm going to have a few of these on the pre-test that I'm going to upload later today. Other than that, there's not really anything too crazy with these types of questions. They are fairly straightforward, so hopefully you guys are getting them. For the test, so I'm gonna leave you with one more just before I end the video, and I'll just leave you guys to work through that. But for the test tomorrow, you're gonna go through thermocouples that we talked about. So the type T thermocouple, all I'm really looking for you guys to know what that is, what type of wire or what color code of wire is going to be used for it. So type T, so TB is blue, your type E being purple, EP, and the type J being white, and the type K being yellow. If you can know those, at least for construction, and also that the negative is red, other than for color code, that's the majority of the stuff you need to know for that. And then really know, what the use of it is. We're looking at that hot junction where the wires are twisted together, that with a flame or a heat source connected to it, that I can produce a voltage. So that ends up allowing electrons end up flowing from one of those conductors to the other one of those conductors in order to get a potential difference. So I'm going to link a video to that and a few other things on thermistors and RTDs. The thermistors and the RTDs, we know that both of those are resistive devices that change based on an applied temperature. So with that, know that a PT 100 is at 100 ohms at 0 degrees, PT 500 is at 500 ohms at 0 degrees. Know that and that they're positive temperature coefficient devices, and the thermistors are typically a negative temperature coefficient device. And just kind of construction. So read through those handouts that I gave you, and that should be fairly self-explanatory as to what I'm going to ask you about. I hope the videos do help you guys out a lot, that I also add to accompany this one. And know your temperature conversion. Be able to go from Fahrenheit to Celsius, Celsius to Fahrenheit. Remember, if we are going in degrees Celsius to degrees Fahrenheit, the number has to get larger. So we take our degrees Celsius times 9/5 plus 32. And then going the other way, we're degrees Fahrenheit, subtract 32. then times 5/9. So that's going to Fahrenheit. This one's going from degrees Celsius to degrees Fahrenheit. So fairly straightforward. And then know your Kelvin and Rankine scales from those charts that I had given you. And other than that, there's not a whole lot of information that I'm going to be asking you to look over. So look over the videos that I'm going to accompany with this one, and then just read through those sheets that I'm providing for you, and you guys shouldn't have an issue with this test. It should be fairly easy for you. So I'm just going to leave one last question for you that you can do. I won't answer it. I'm just going to leave it for you to practice with. 500 ohms on R1, 500 ohms on R2, and notice it was 20 volts power supply, not 10. And we're going to do 750 on R3. Actually, no. Let's do 1000 on R3. And we're going to have a PT 1000 again. We are going to have, so 0 degrees Celsius is equal to 1000 ohms. Temp is at 50 degrees, no, let's do 57 degrees Celsius, and we change, let's do 25, let's do 2.5 ohms per 1 degree Celsius. All right, so if you can go through and bang that one out. So if you can go through and bang that one out. Sorry, I don't know if that's gonna show up. I had a little power on my iPad. But if you can go through and figure that one out. 0 degrees, 1000 ohms. Temp is at 57 degrees Celsius, 2.5 ohms per degree. And we've got 20 volts, 500, 500, 1000, and PT 1000. Go through and bang that one out, and you shouldn't have an issue on the test. Okay? All right. Good luck on your test and the pre-test. Thanks. Bye.